Hi guys, today we're doing one of my favourite experiments from a teaching point of view, and in fact this is an experiment I cover absolutely every year, have done ever since I became a teacher. It's an internet favourite, and it's the Coke and Mentos experiment, or I should maybe say Cola and Mentos experiment, just to not show any brand loyalty. So, the experiment itself, in and of itself, I would say definitely falls under the edutainment category. However, we're going to be doing it with a slightly more scientific twist, and within a lesson context, the whole point of this is to encourage our kids to think about scientific methodology, how to formulate a hypothesis, and how to create a fair test. And that's why I do it every year. I do it every year, right at the start of the year, before I've started any of my other science topics. It's usually a week 1 or week 2 experiment for me, because I think it is just so powerful in terms of getting kids to think like a scientist. So first of all, what I need my class to do is think about what their research question is. And you can pose you can pose several different questions. It could be, does it fizz up more when you put one mint in, or when you put 2 mints in at the same time? Does that create more of a fizz? Does a bigger bottle fizz up more than a smaller bottle? Does one particular cola drink fizz up more than another particular cola drink? Or does a cola drink fizz up more than a lemonade drink? You could choose any one of these research questions. The research question that I'm choosing, and that I tend to try to guide my class towards, is to do with whether the size of the hole at the top of the bottle makes a difference as to how high the liquid goes. So, the way we're going to do that is we're going to have one bottle with the lid off, and another bottle where the lid is going to stay on, but we're going to create a hole in the top of the lid, which I'm going to do now. So I've got just a standard lid. I'm going to take my tool here and just create a hole in the lid. Okay. Now, once you've come up with your research question, your job as the teacher is to, first of all, get the kids to think about how to make a fair test. The rule in science is that we only change the things that we are wanting to test. So the only thing that we can change between 2 different tests is the variable that we are actually wanting to measure. So in this case, I'm wanting to see whether a bigger hole or a smaller hole fizzes up more. So in this case, the only thing I'm allowed to change is the hole size. I would not be allowed to put one Mento in one of them and 2 in another, because that would then mean that the variation that we're seeing, the results, could be due to either one of those things. It could be due to the hole size, or it could be due to the number of Mentos. Likewise, I couldn't use 2 different sizes of bottle, or 2 different brands of cola. If I'm wanting to measure the hole size, the only thing that changes is the hole size. So first of all, I get my class to understand that and to buy into that concept and actually understand why that's the case. After I've done that, though, what I try to do is I almost try to sabotage it. Now, this is just something that I demonstrate in front of the class. I usually take them outside for it, but today I've planned ahead and I've actually put some plastic sheeting on the roof. No expense there. So, while demonstrating it, I'll ask them questions to try to sabotage it. And of course, they want to see the biggest fizz up that they can. So I'll say to them, right, okay, we're testing the hole size. Tell you what, I think it'll fizz up more if we put 2 in one of them. Should we do that? And they'll all say yes, and then 1 or 2 of them will realize, no, that breaches the guidelines of a fair test. No, we can't do that. Okay. Well, I'll tell you what, if as soon as I drop it in, I fizz up one, I shake up one of them, that'll really make it fizz up. Should we do that? And similar reaction, but probably a bit more muted this time. A few of them will say, yeah, let's do that, and more of them will be saying, no, because that's changing another variable. So already, just in the course of one lesson, it starts to sink in what we're actually trying to achieve here. So we've come up with a research question. We've generated our hypothesis. We'll generate a hypothesis to which one would fizz up more and why. Then we actually have to do it under fair conditions, changing only one variable. So I've got I'm going to be putting one Mento in each of them. But lastly, to keep it truly fair, I would actually need to measure the height of each one and keep it as fair as possible. So we'll do this now, just for the sake of it. I'll put one to the side. Now, it does help if you can record this, which obviously we're doing just now, and actually physically measure the height of the fizz. So we'll do the two of these, one after the other. Here's the first one. So this is with the biggest hole, and it's great if you can slow it down, put it in slow motion, that sort of thing. So we'll just drop this in the bottle and measure how high it fizzes. Wow, isn't that exciting? Always fantastic. And your class will give you a rather disappointing, a disappointed reaction, as you might expect. Okay, so not a great fizz there, not what you were perhaps anticipating. Then we do this one with a smaller hole. There's a reason for the plastic sheeting I put up there. Now lower it on carefully while you screw the lid on. Make sure we're in a position to measure. Rule it round the wrong way. And off we go. Oh, it didn't go as high as I anticipated there, but still a much better reaction. Smaller hole, it goes even higher. I have managed to hit the roof in the past. Really good experiment, really fun experiment. Can just be edutainment. However, I've knackered my phone now. However, if you introduce it by encouraging them to think about different variables and how to control variables, then you massively increase the educational impact of this experiment. And like I said, I do this every year, and it really, really works. They remember it for the whole year. Cheers.